Hello, everyone, and thanks for joining another episode of the Trellix Spotlight series. We're going to wait another minute to give everyone a chance to get connected, and then we'll get started. Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on the network security platform's AllowList, BlockList enhancements. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our presenter today is Vidya Lakshmi Vilvamani. Vidya is a technical lead at Trellix, and she currently supports the NSP Q&A team. Vidya also has a bachelor's degree in electronics and communication. Ladies and gentlemen, Vidya.
Thanks, Nick. Hello, everyone. I'm Vidya from NSMQA team. Today, we'll be going over the feature called IP AllowList BlockList Enhancements, which went in 10.1 M9 release. So here is the agenda. We'll start off with the overview on why this feature was brought in, and then the scope on what's been included in the feature for this release, the applicability or the supported platforms where the feature fits in, followed by the demo, and then the troubleshooting steps. To start with, I'll give you a small background on why this feature came in. So firewall policies and rule objects are used as the basic building blocks in the sensor, essentially to allow or block the traffic matching the specific IP addresses. And here, what's a rule object? A rule object is nothing but the list of members. So these members could be anything like application, service, host name, time period, could be endpoints, address range, or network. And this depends on the type of the rule object chosen in NSMUI. So certain rule object types are deployed in the source and destination address fields of the firewall policy. And this firewall policy is then applied on the sensors interfaces, and the configuration is pushed to the respective sensor from the NSM. So accordingly, the traffic matching the IP addresses are allowed or blocked by the sensor. Again, this depends on the response actions which have been configured in the firewall policies. So before 10.1.M9, we supported a maximum of just 10 entries in the rule objects associated with the policies. However, the primary requirement from the customers was to use a larger list of IPs, basically from the third-party IOC feed, and thereby allow or block the matching traffic. So for this purpose, in 10.1.M9, enhancements were done in the rule object configuration, the association of the rule objects in the firewall policy, and the corresponding deployment on the sensors. Now moving to the scope on what's there in the release. So the member limits have been expanded for certain rule object types such as IPv4, IPv6 endpoints, IPv4, IPv6 network, IPv4, IPv6 address range, and host DNS name. So the maximum limit for endpoints and network is 140K, for address range is 20K, and for host DNS is 5K. The other rule object types, such as application, service, time period, etc., those remain unchanged. Also, we have provided an enhanced UI support in NSM, which enables the user to perform all sorts of operations that they want to do. And also, here's the most significant part. Supporting the usage of large list of IOCs has been implemented through 3 ways. So the first method is the manual creation of IP addresses in the rule objects from NSM UI. The second method is the NSM CSV import feature in the rule object to manually import the larger list of IPs. And the third method is using the NSM SDK API for automatic ingestion of the third-party IOC feed. Now coming to firewall rule object real-time auto deployment. For certain rule object types such as IPv4 and IPv6 endpoints and IPv4, IPv6 network, if there is any change detected in the list of entries, it could be anything like it could be addition, modification, deletion. So such changes can be automatically deployed on the corresponding sensors with the associated firewall policies, which are actually using those rule objects. And this goes as a network object update called the OOB file, the out of band file. And yes, there is a setting introduced for this in NSM UI, and that's been disabled by default, but it can be enabled upon the user's configuration. It's actually a global setting which is applicable to all the domains. Also, we have UI level validation with proper error or warning messages wherever required. So this especially comes into picture when the threshold or the rule object limits have been exceeded or associated with an incompatible sensor software. Now coming to the applicability or the supported platforms. So all these changes, all these enhancements are applicable only to sensors running 10.1.M9 software or above. So different sensor models like 9X, 7X, 5X, VM series, etc. have different predefined limits on the cumulative rule object member count. This actually depends on the licensing and the throughput that the sensor model supports. So config update of the sensors will eventually fail if those limits are being exceeded. So it has to be taken care. And apart from NSM, the feature has been extended to NSCM as well, which is the central manager here. So the rule objects with higher limits can be created in NSCM. The same gets synced to NSMs managed by that central manager. And these rule objects can then be used in the firewall policies which are applied on the sensors attached with those NSMs. So coming to the hetero mode, in case of hetero mode, when a 10.1M9 NSM has pre-10.1M9 sensors connected, all these enhancements are not applicable. Again, the higher limit rule objects are not supported. And again, the notification for the same is provided in NSM in the form of error messages. So coming to the non-firewall policies, apart from the firewall policies, the rule objects are also being used in other policies like quarantine zones, SSL decryptions, ignore rules, QoS, etc. So there is absolutely no change in these non-firewall policies, and they continue to use the legacy rule objects. The rule objects with higher limits cannot be associated to non-firewall policies, and the proper error notification is shown under those conditions as well. So here is the sizing of rule objects on various sensor models. If you take a firewall policy, there are various fields, including the source and the destination address fields. So in this feature, we have increased the limits on the source and destination address TLVs. For instance, if you take a sensor, say NS9500, which is running a throughput of 30 gig, the source and destination address TLVs prior to this release had a support of maximum 40K. But that has been increased by 100K and becomes 140K now. So this is the cumulative limit of source plus destination address fields. And hence, the cumulative count of all the fields in the firewall policy goes up from 140K to 240K. This particular example can be seen in the first row in the given table over here. So accordingly, these slides show the same data for various sensor platforms. So towards the left are the various sensor models. And on the right, we have two sections. The first section describing the limit in the source and destination address fields of the firewall policy. And the second section describing the cumulative limit in the firewall policy. Now, coming to the rule object member count limits in NSM. So these are the maximum rule object member limits which can be attained or configured in NSM. So for rule object types such as IPv4 endpoint and IPv6 endpoints, the maximum rule object member count limit is 140K. For rule object types such as IPv4 network and IPv6 network, it is again 140K. For IPv4 address range and IPv6 address range rule object types, it is 20K. And for host DNS, it is 5K. So going beyond the limits for the corresponding rule object types will not be allowed. And again, it will pop up an error message accordingly. So now let's get into the demo of the feature configuration. So here I have the Network Security Manager launched, and under the Policy tab, we see the rule objects node. So this is the default view of the rule objects page, where we will be able to see both the custom as well as the default rule objects. Now I'm going to create some custom rule objects, and that can be achieved using the add button over here at the bottom panel. So I give the name and I choose a type as IPv4 endpoint. And here I can create an entry. I say add and save it. So now the rule object has been successfully created. And using the other options like the clone option, the delete option, we can do the corresponding actions on the rule object entries. So now we have one more called the Save as CSV option here at the bottom panel, which enables us to import the grid. And let's view the details of this particular rule object. So this is the new enhanced UI support that we are bringing in this feature with this release. And under the properties tab, you'll be able to see the rule object details. The rule members tab will give you the list of entries, whatever you have configured or added. And in the bottom section, within the rule object, we see the add button, the delete button. We can perform some operations on the rule object members. And again, the save as CSV option, which enables us to import the grid content. Now, I want to create a rule object with the maximum limit that we are introducing in this feature in this release. So let me try creating another rule object. This time rule object 2, and I choose the type as IPv4 endpoint. So now it is not feasible to add all those 140K entries, the higher limits, all manually, right? So, and that is why we have introduced the CSV import option here. So, which is available under the other actions. So you click on the other actions, you see the import option and just click on that. Now the import dialog window will show you two options, one being append and the other being replace. So if you already have a list and if you want to append to that list, then probably you can go ahead with the append option. Or if you want to override the list completely with a new list of entries, then you can choose the replace option. Now, since I don't have any entries, I'm just going ahead with the append option. Now I'm going to import the CSV file, which is containing the 140K entries. So now I browse and I import the CSV file. And save. So now the rule object has been successfully created. So let's get into the details. Here we see all the 140K entries. Whatever we had in the CSV file, that's been successfully imported and now it is included as part of the rule object. So here we see the total count that is present within this rule object. Yes. So now having created these rule objects, I want to assign this rule object, especially the higher limit rule object, which is having the maximum limit on a firewall policy and eventually apply that firewall policy to the sensors interfaces. So now I'm navigating to the firewall policy node. I already have a firewall policy created here. So now I will apply the higher limit rule object, which is rule object 2 in the source address field of the firewall policy and save it. And I have applied it to this sensors interface. So now we have created a rule object with the higher limit. We have associated that rule object with the firewall policy and we have applied the firewall policy on the sensor. Now we will push the configuration to the sensor from NSM. So here I'm going to deploy the changes. So let's wait for the SIG push to complete. So now the SIG file has been successfully transferred to the sensor. So we can validate the same under the sensor as well using the download status command. Yes, it has received the configuration. So now I'm going to generate a traffic which is matching those list of entries in the rule object that we had configured. And I have set the response action as drop in the firewall policy. So the corresponding traffic matching the entry should get dropped by the sensor. So I've started playing the traffic. And now we see that the traffic, whatever is configured to block, right, according to the policy and the rule objects and all, it's being dropped by the sensor. Show inline packet drop stats all is a legacy command. It doesn't include any new changes. Now, coming back to NSM. So earlier I was mentioning about the firewall rule object auto deployment. So we have a setting for this in NSM, and that's been newly introduced with this feature in this release. And that's available under Devices tab, Global tab, and here under the IPS device settings, you see the firewall rule objects. This particular setting is disabled by default. You can find the information under the information icon over here. So basically, for certain rule object types such as IPv4 v6 endpoints, IPv4 v6 network, if we make any changes, we can add, we can modify, we can delete the entries. So those changes will be automatically detected and it will be pushed to the sensor in real time. So there is no manual intervention needed. There is no necessity to go and deploy the pending changes. So how do we achieve that? So for that particular setting, we need to have this configuration enabled. I'm going to enable this configuration here. Yes, now it is enabled. And then we have applied this particular rule object in the firewall policy. So I'm going to make some modification here. Say I'm going to delete some entry and add a new entry instead. And update. So now this change need not have to be pushed via deploy pending changes because it will be automatically transferred to the sensor from NSM. And how do we confirm that? We can refer to the logs in this particular log file called Rule Objects Deployment Manager. And this is a new log file which has been introduced in this feature. So I'll show you the contents of the log file. So here Um, it's been recorded, the actions that whatever we perform has been recorded here. So initiating deployment, generated rule objects file, and rule objects file has been transferred and applied successfully. We can also confirm this on the sensor using the download status command. So this particular counter has been added to the download status command. This is a command which is already existing in the sensor, and this particular counter has been added. So you see firewall out of band file downloaded 1 because it has been received from NSM, and it shows the corresponding status and the count. Also, this particular change will not trigger anything under deploy pending changes. And you see that the checkbox is not enabled because we have enabled the firewall rule object auto deployment setting. And so everything has happened in the background and everything has occurred in real time. So there is no need for any manual push from here. And that is why the notification is not shown to the users. Yes, so as we saw just now, we can refer to the rule objects deployment manager.log. The file transfer SIGPerf logs also help. And also we can refer to the generic logs like EMS out in case we encounter any error or face any issues. On the sensor side, we already had the download status command, but this particular counter has been added to that command, the firewall out of band file download, its status accordingly. And we also have this legacy command called the show inline packet drop stats all, so which will show you the ACL drop count. So I can tell you some pain points which we face as of today. Like we've been facing the usability issue on importing the larger list of bad IPs which are meant to be blocked, right? So every time when there is a huge list of compromised IPs in thousands and 10,000s, so the old ones had to be deleted and then the new list had to be put in buckets of 10 since each rule object had a limit of just 10 entries in earlier releases. But now with this feature coming in, such problems could be avoided. Customers can either go for the CSV import of large list of entries or the automatic ingestion of the IOC feed through NSM SDK API. And also we have the support of append and replace options, and the existing rule objects can be updated easily till the threshold limit. Uh, yes, and also certain functionality issues can also be resolved now given that the higher limit is supported. This actually paves way for the users to have a different approach and it can really simplify their automation. This is also more flexible from the regular approach where some of our customers seek the help of professional services to have automated scripts to inject the list of compromised IPs which have to be blocked, right? Yes. And so these are the firewall and rule object statistics which are retrieved from the binary file generated within the sensor. But this is only used for our internal debugging. It provides information on the firewall policies, the interfaces where it has been applied, and also the details on the rule objects associated with it. This is only for internal troubleshooting. So here is the sample CSV file. This contains the higher limit or the maximum rule object member list. This particular file supports two columns, the rule object entries and the comment column. However, The comment column here is optional. And also this CSV file, as shown already, can be imported from NSM UI. And we saw this during the demonstration. And yes, you can also find details on the rule object configuration, the new UI support, and the firewall rule object limits on the NSM help page as well. So these are some examples on how the NSM UI validation has been handled. The errors or warning notifications have been taken care wherever required. If you see this particular slide, we have three snapshots. So the first snapshot throws up an error message, um, which comes up when we are trying to assign the rule objects with the higher limits to an incompatible sensor. In the sense, a sensor which is running an older version, that is pre 10.1 M9 sensor. So this particular error message will be seen when we try to associate the firewall policy containing the rule object, higher limit rule object, with the incompatible sensors. And the second snapshot is the compilation failure when we are trying to exceed the limits in the source and destination address fields of the firewall policy. So as told earlier, every sensor model has some predefined limits for the source and destination address TLVs. So when we are trying to exceed those limits, we will come across this error. And the third one is regarding the maximum rule object member count limits in NSM. So when we are trying to configure any rule object in NSM UI and have the entries more than what it actually supports, then we will be seeing this error. So suppose if you take a particular rule object type, say V4 endpoint or V6 endpoint, V4 network or V6 network, the maximum limit that it supposes is 140K. And when we are trying to exceed it, then probably we will see this error. Yeah, so this is all about the feature and the demo. Thank you all. Over to you, Nick.
Thanks, Vidya. As a reminder, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated.
Can I add a CSV from a network location and update it automatically? I will take that one. So in NSM, we have NSM SDK APIs, and there we have added a new API using which we can ingest the content from a CSV file. So our customers can write automation, and in that automation, they can call the NSM SDK API and pass the CSV file. And that's the way it can be ingested into the NSM and IPS.
Got it. Okay, perfect. Thank you for that. My customer uses a firewall policy with a list of bad IPs from their threat intelligence provider. When they deploy the policy on a sensor, they often get the error exceeding rule objects limit. How will this feature help my customer?
Yes, so with this enhancements in 10.1 M9 sensors, we have allocated more memory and optimized the rule objects in the sensor. So with this more memory and optimizations, the sensors will provide enough headroom for our customers to deploy larger list of IP addresses on sensor.
Got it. Okay, perfect. Thank you for that. Is there any recommendation on how we should apply firewall policy with a large list of IPs on the sensor? Should we apply a device level or interface level? And how does that impact the sensor limit?
Yeah, good question. So if a firewall policy contains a large list of IPs, say it's from a threat intelligence provider, then the recommendation is that the firewall policy should be used in the device level. So if when the firewall policy containing rule objects are applied on a device level, the sensor counts them one time. And if the same firewall policy with rule objects is applied on multiple interfaces of the sensor will count them for each interface. So in case of a large list, the multiple interfaces means it will be counted multiple times and it will exceed the sensor's limit. So the recommendation here is it should be applied at the device level.
Got it. Okay, perfect. Thank you for that. My customer has written complex automation scripts having several steps, which reads a large list from a CSV, it breaks it into a group of 10, and it deletes existing rule objects and firewall rules in NSM, then creates new rule objects and firewall rules and assigns them to a firewall policy and pushes that configuration to the sensors. These complex automation steps run every time our customer gets a new file. How will this feature help my customer?
Yeah. So we understand that in past, our product didn't have the native support for ingesting of large list of IPs from external file, and that's when customers ended up seeking professional services help and writing complex scripts to ingest those things from external file, and that's inefficient and difficult to maintain such automation. So with the rule object enhancements in this particular release, and introduction of a new simplified NSM SDK API using which we can now import IPs from external file, and the customers can extremely simplify their automation by making just one simple API call. So there's no need to delete or recreate the thousands of rule objects and the firewall rules anymore. Instead of that, they can just update the rule object by calling the API, which will take rule object ID and the CSV file, which contains the new entries. And the rest of the job will be done underneath by NSP.
Got it. Okay, perfect. Thank you for that. What happens if there are any duplicate entries while importing a CSV file containing a larger list of IP addresses using the append option?
So the duplicate entries will be ignored, and the CSV import will be taken up for processing, and the rule object will eventually be created, or it can be modified also. But if the count in the number of entries in the rule object is going to exceed the maximum rule object limit count, what we support, then the user will be notified with the error messages accordingly.
Got it. Okay, perfect. Thank you for that. Given that we support enhanced limit rule objects and the firewall policy is deployed on the sensors, can there be any performance issues?
Yeah, so considering the applicability of the higher limit rule objects in the firewall policies processed by the sensor, and also the resources allocated, so the code optimization and workflow has been taken care in various sensor software modules within, in various software modules within the sensor. And also the issues which have been caught during our internal validation have also been resolved. So.
Got it. Okay, perfect. Thank you for that. Does the firewall rule object auto deployment happen to all the sensors when the rule objects are updated?
No. The firewall rule object auto deployment happens only when the modified rule object, which is of type IPv4 and IPv6 endpoint, or IPv4 and IPv6 network, is deployed inside a firewall policy associated with the respective sensor. So for this action to take place, we need to have the firewall rule object auto deployment setting under devices in NSM to be enabled.
Got it. Okay, perfect. Thank you for that. How can I migrate multiple rules with multiple objects with the old limitation of 10 to one simple rule with a big object?
For that, there's no automated way as such, but we can leverage the export and import functionality. So we can export multiple rule objects into CSV and then combine them into one CSV and then import it into a new rule object. I think that would be the way to do that.
Got it. Okay,
Finally,
perfect. Thank you.
finally,
Oh, sorry.
the limit for the maximum number of rule objects present in a firewall policy or a firewall rule only counts. So unless and until that particular threshold is not hit, we allow the association of multiple rule objects within a single firewall rule or a firewall policy.
Got it. Okay, perfect. Thank you for that. I think that looks like all the questions that we had for today's session. I want to thank everyone for joining today's webinar, and a big thank you to Vidya. As a reminder, a link to today's recorded presentation will be emailed to all participants. This concludes today's webinar. Stay safe, everyone.